Let's say you're developing your own software product, either for yourself or the company you are working for. The product could be a payment processor, ERP system, or AI tool, or even the database, as in my case, which I will be discussing today. For your product, you want to increase revenue, and you will do this by increasing the number of users. To achieve this, one strategy is to ensure that the product can be integrated with other products, thus providing additional value for your clients. So, in order to do that, you can create an API interface, and let's assume it's a standard REST interface using HTTP methods on the side of your SaaS product, and it has simple methods like get, post, boost, patch, delete, head, and options, and so on. And then your developers and or other developers can create different apps and services that will connect to your SaaS application. When you create an API service, what you also want is to lower the barrier to entry and help developers create these integrations with your product more easily. You will achieve this by creating the API for your product. So we will create that API and they can use it to connect easier. But in which programming language you should create that? Most often, it's the one you're already using to develop your product. So we are developing our product in C#, and our main client was created also in C#. However, there are developers who create their product in different programming languages and want to also use your product. So in that case, you will develop a client in that other programming languages as well. So soon you will have several clients, and instead of just maintaining your product, you now have to maintain also multiple clients in parallel. So what should we do in that case? There are several development approaches how to develop these libraries. And this brings us to the purpose of today's lecture, to explore different approaches and strategies that will help us efficiently develop and maintain API clients across different programming languages. So what kind of development approach do we have? There are three different approaches for developing client libraries for multiple languages, and they are code generator, transpiler, and you can write your own libraries on your own, completely on your own. For the code generator, the question that we should ask is, can I use some API client generator? Something like Swagger, CodeGen, or AI code generator. Answer here is typical engineering one. It depends. If your client is just a wrapper for the API calls, then you can. Otherwise, not. This means that the logic in the client can extend beyond what is provided by the API interface alone. For example, a RavenDB cluster is made up of multiple nodes, and the client contains the logic to determine which node should handle each transaction request. So this means that the node balancing logic is implemented directly into the client, ensuring that if a call to one node fails, the client will automatically attempt to send the request to another node in the sequence. In situations like this, code generators cannot be used. Okay. The next question is it possible to automatically transpile code from one language to multiple others? It is a great idea that business logic written once can be compiled into different programming languages. When adding new features or fixing bugs, you only need to do it in one place. And then that logic will be transpiled to other languages, and you are just compiling all the client's code and you are delivering them. There are several solutions for this, and most famous is the Hex, and it has its own language that can be directly transpiled to JavaScript, C++, C#, Java, Python, even the PHP. And in the end, this is the great idea, but with using something like this, you're adding an additional layer of dependency when you're building your client library. And that can cause some significant issues in the future. So you might want to create some custom methods that are difficult to transpile into other language, and you will be stuck to figure out how to set up your transpiler to compile it in order, and maybe it is very simple to just write in one language and in another language and use it. Or sometimes new language features are released and you want to use them, but you're stuck waiting for the new transpiler release that will support that language release, which may sometimes be unreliable since its development is community driven. So if these two are not option, what shall we do? Our option is to write our own libraries, so from scratch. And how to do that? We will use some strategies for developing libraries, and that is the main message of this talk. So first strategy for developing libraries is to use single source of truth. So one client must be the primary one. But I mean, its library code is the first place that is written. All new features start from it, and they are implemented there first and then mirrored to other clients. Similarly, all bug fixes begin with it. So if you find some bug, you implement it there and then just write it to the other libraries. Second strategy we use is to start with tests. Okay, we are not speaking about TDD tests, but behavior-driven development is definitely something that makes sense. So which test we should create here first? First, we should start with happy path testing. So when you add a new API call in your library, just create tests that will call it and check if there are no exceptions. And that's it. Simple as that. Also, when you find a bug in your library, you should start with the test before you fix that bug. So usually when the bug occurs in the one library, it probably occurs in the different in all the other libraries, if that is a business logic bug. So when you fix it in one, it is very simple to apply that code fix in all the other libraries. This way, when you create these basic tests, you have the same set of tests everywhere. And all these tests become regression tests to prevent bugs from reappearing in the application later. Note one more thing. that all these tests should be automated, and their execution on GitHub Actions or some CI/CD platform is mandatory and should be run at least every 7 days if your main product is actively developed. So even if no changes made in your client code, you should run your test against the main application in order to check because something could be changed there. Next strategy we should deal with is the separate infrastructure from business logic. So every well-designed application architecture should start with this and separate these two things. And the same principle that applies to normal applications we are developing applies also to the client libraries. So how we can do this? First thing first, we should physically separate the code into the different folders. That means don't mix business logic code with infrastructure related code. And just like when building an application, it's the best to create folders like domain, infrastructure, and application. And we all know application can access to domain, infrastructure can access domain, but application cannot access infrastructure, and infrastructure to application, so on. Okay, next thing that we should also introduce is to create domain classes to use with your business logic, and their implementation will depend on the programming languages or the library you are using. You want to avoid primitive obsession. What is native to one programming language may not be native to other, and also you can maintain your code much easier this way. For example, we have here this class temperature, so checking if the temperature is valid, has a valid value, we are doing that check only on single place in all our application. The other example, what is very, very important to create your own class that will be moved through all the other clients, is the classes that work with the time. So time intervals are defined differently in C#, in Java, and PHP. So create a single domain object, let's say duration, and implement it in each programming language with the same interface. But definition of that depends on the language. So since it has the same interface, it will be used consistently in the application. And here we should always remember the golden rule, composition over inheritance always apply, and it always wins. If you use additional libraries, for example, like HTTP client library, always create an adapter for them. Never use these libraries directly inside your code. So because this is the part of infrastructure, not part of your business logic. And always introduce adapter with the same interface across all programming languages to ensure that the business logic remains identical everywhere. So composition over inheritance is applied here also. And sometimes we should definitely use advantages of language, as we can see here in this simple example. What this means: some programming languages have built-in functions that others do not, such as data serialization or converting ISO dates. Always use these functionalities through an adapter, just as we described for additional libraries. For example, when converting ISO dates from and to strings, our team in Java had to create custom classes that will deal with this formatting, while in PHP, simply it used an adapter for those calls and integrate native functions. We just had to set up the right format for it. All previous examples show us basic techniques we should use to separate our business logic from infrastructure. And beware that this is not just technique we should use only for library development, but also for all our application we develop. Now, something that is specific for clients. When you write your business logic, always write it in consistent manner. What does it mean? It means that all our code should be written in the same way in all the different languages. As you can see here, on the left side is the Java code, and on the right side is the PHP code. You can see here that we are using the same variable names, same method names, order them in the same way, and even throwing the same type of exception. This is important to have simple maintenance of your code. So if you fix something in original library, you just find the same place in the derived library and apply the change. This means that some bug fix found in business logic of your library can be propagated to all library in a single day. One method that I used when I developed the PHP library is the copy-paste technique. So to ensure that everything is implemented consistently, even for features not yet added to the derived libraries, I used this copy-paste technique. When I started working on the RavenDB PHP library project, the other libraries were already developed. So I needed a way to quickly add new features without constantly referring back to the original code. For example, I created the document query class, then copied the entire class code from Java and commented out everything. Next, I created a test and only uncommented and translated the segments needed for a specific test in PHP. I repeated this process, creating a new test and translating the necessary parts for each one. This approach makes it easy to see what has been implemented and what is still pending. Additionally, since comments do not impact code execution speed, even in interpreted language, they are useful for documenting the state of the implementation. This method is also helpful when certain functionalities are either not feasible or not desired in a specific programming language. For future maintenance, it's important to know that a section of code was intentionally left out, not forgotten. For example, PHP does not support multi-threading, so any flags used as semaphores would simply be commented out and left in the code for the reference. By implementing only the necessary code for each individual test, you avoid the waterfall trap of needing to complete everything before running the first test. This allows you also to focus on one feature at a time and have a library with the basic functionality from the very beginning. One more thing that we should be careful is to avoid method and constructor overloading when we create our client libraries. You must be aware that some languages, like PHP, doesn't allow constructor and method overloading. And when you try to recreate library like this one, you need to make some compromises. So you can see here we have two methods with the same name, time series, with different parameters. Let me just show it. Yeah. And in order to implement it in PHP, we need to make some method resolver that will take us to the right method here. The second thing we have here, also in Java, in C#, we have this time series for, also with the same name, different method, but in this case, we have different returning type. And when we have this kind of situation that it should return different types, method resolver doesn't help us here. So we need to create another method, but now with different name. And that's the issue we have with this. So okay. Same goes with constructors. So better use name constructors in order to have consistency in your code. Otherwise, we will have situation that we have constructor based on parameters in one language, and in other language we will have that named constructor. And now which one to use it, actually we can be a little confused. And that's it. So let's revise. Strategies for development that we should use are single source of truth, start with the test, separate infrastructure from business logic, write business logic in the consistent manner, and avoid method constructor overloading. So that's it. Any questions? Okay. Thank you all, and goodbye.